Assalamu alaikum, dear students. Welcome back to another lecture of structural analysis. In this lecture, we will discuss about an example and their solution based on virtual work method. But before starting the example, I am going to discussing about that what is virtual work method. Basically, in virtual work method, if we are required to find the displacement at any particular point, then we apply unit virtual load on this point, then we find their internal reaction such as movement. So there are two type of movement. One movement occur due to virtual load and one movement is occur due to real load. Okay, so then after we multiplying these two movement and apply integration on that. Okay, now if we are required to find the slope at any particular point, so then we apply at that point unit couple movement. Okay, so after that we will find the internal reaction due to unit couple movement and real load movement. For example, we apply some real load, so they will be provide some movement. Okay, so combine after multiplying these two movement, we apply integration on it. So then the result is should be in the form of divided by EI, and the result should be in the form of radian, and the deflection result should be in the form of millimeter or meter or feet. Okay, so now I am going to discussing about how we can solve example based on virtual work method. Okay, so this example basically I have chosen from R.C. Hibbeler book structural analysis. Okay, example number 9.7. So example number 9.7, determine the displacement at point B of the steel beam shown in the figure. Use modulus of elasticity is 200 gigapascal and moment of inertia is 510 power 6 mm power 4. Okay, so here in this question I have given a cantilever beam. So what does it mean by cantilever beam? A cantilever beam basically supported by one support which is fixed support, and another side of cantilever beam is free. Okay, you can see here this side is free and this side is fixed by three support. Now what does it mean by fixed support? Fixed support mean that they resist three type of reaction such as vertical reaction, horizontal reaction and movement. Now what does it mean by horizontal reaction, vertical reaction and movement? Horizontal reaction means that if we apply some load on this beam from this side to this direction or this direction, so this support will be resist these horizontal sliding or these horizontal displacements. Okay, now in this question currently apply UDL load 12 kN per meter downward, so they create shear forces on this beam, so this shear force will be resisted by this support. Okay, now this load also create a clockwise movement, so their resistance should be anti-clockwise, which is resisted by fixed support. Okay, so my point is this: the fixed support resisted three type of reaction: vertical reaction, horizontal reaction and movement. Okay, so in cantilever beam we are used fixed support. Okay, so the applied load is 12 kN per meter and the distance of the beam is 10 meter. So 12 kN per meter mean that the load is UDL. If this value is given in 12 kN dot meter, then that mean that there is some movement given. But now 12 kN per meter, so it means that this is the UDL load. Okay, now what is the target of our question? The target of our question is to determine the deflection at point B. Okay, now if we apply 12 kN per meter load on this beam, so what will be the displacement or deflection at point B? It means how much point B will displace from original point. Okay, so due to virtual work method, what we will do, we will apply unit load on this point. Okay, so according to virtual work method, we will apply 1 kN virtual unit load on this point, and we will take coordinate from the beam. Okay, now what does it mean by coordinate? Coordinate means that we are suppose some distance from this point like x, because this beam, total beam is 10 meter, but we can take section like x distance. Okay, so we have applied 1 kilonewton virtual unit load. Okay, so now what will be our second step? Our second step, we will find the internal movement on that point, then this movement is called virtual movement. Okay, so we separate this section from the beam which is on x distance and 1 kilonewton virtual load applied, and this is point B. On that point we will find the movements. Okay, so there is one shear force will produce due to this load, and one is the internal movement will be created. Okay, so this movement we will represent by small m. Okay, so now what we will do, we will find the movement along this point. Okay, so summation of movement at this point is equal to 0. Now this we can take anti-clockwise movement is positive and clockwise movement is negative. So this movement along this point should be clockwise, which is we consider negative. So negative m minus, on this point the movement will be created in the form of point load, which is 1 kilonewton multiplied by its perpendicular distance. So 1 kilonewton into x, the sign of this movement will be negative because they provide a clockwise movement. Okay, so after shifting this m into the equality sign, so this will be positive. Okay, so positive m is equal to minus 1x. This is the virtual movement of due to this load. Okay, this is also called internal movement at that point. Now we are coming toward the real movement, that what is the real movement of this beam, because when we apply 12 kN per meter load, so there will be a movement will be created. Okay, so real movement due to real load. Okay, now we have taken again section at x distance from point B, and the load is applied 12 kN per meter and the total distance is 10 meter, but we neglect this 10 meter distance now in this step. Okay, so we take again section at x distance, and there will be movement created and shear force will be created due to this applied load. Now convert the UDL load to point load. So how we convert the UDL load to point load? If we are needed to convert the UDL load to point load, so we must be convert this UDL load at horizontal distance, and this load shall be applied on the center of this area. Okay, now you can see here, this is the x distance and 12 kN per meter load applied. So what will be the resultant, or what will be the concentration, the intensity of this load? So 12 multiplied by x, so this is the convert to point load, and this is the intensity of this load. Now where this load is applied, this point load is applied in the center of this x distance. So how we can know about that what is the center point of this x distance? Okay, so x divided by 2 will be the center of this point, and x divided by 2 will be from this side of the point load. Okay, now what is our next point from this point? Okay, so we will find the movement at that point. So now summation of movement along this point is 0, and the anti-clockwise movement we will consider positive, and the clockwise movement we consider negative. Now from on this point, this movement will be created positive movement, negative movement mean clockwise direction, negative movement, and again this point will create clockwise movement. Again this is we consider negative. Okay, so 12x, okay, multiplied by perpendicular distance will be equal to x by 2. So 12x into x divided by 2. Now after simplifying this, 2 and 6 to 12. Okay, and x multiplied by x is equal to x square. Okay, so after shifting this minus m to the equality sign, so this will be equal to positive m. Okay, and minus x square again remains same symbol. Okay, so m is equal to minus 6m cos square. This is capital M represented by capital M. So this is the real moment developed due to real load. Okay, and this one is the virtual moment and developed due to virtual 1 kilonewton load. Now what we will do, and next step we will put these two movement, real movement and virtual movement, and this equation. This equation is equal to 1 kilonewton dot delta B is equal to integration of 0 to L small m and capital M divided by EI and dx. Now what does it mean by small m and capital M? Small m mean that virtual movement, capital M mean that real movement which is developed due to real load. Okay, so now we are putting the value in this equation. Our virtual movement is minus 1x and real movement minus 6x cos square divided by EI. Okay, so after computing this value and scientific calculator, we will get the result of this equation, which is equal to 15 × 10⁻³ kilonewton dot meter cube. Okay, now what does it mean by 0 to 10? 0 to 10 mean that from 0 point up to 10 meter what will be the deflection. That's why we integrate whole area. Okay, now what is our further step? In next step we will put the EI value in this equation. Okay, so the value of E is equal to 200 gigapascal and the value of inertia, moment of inertia, is 510⁶. But there is totally different unit here are used. Okay, you can see here this is meter, and again this is millimeter. So when we compute this value with the help of different units, so our answer will be wrong. Okay, so it is necessary for this to all the unit, numerator unit and denominator unit, all unit will be same. So that's why we convert this millimeter into meter. Okay, so our result should be in the form of meter. So after computing this value on scientific calculator, we will get the result 0.150 meter. Now according to the hibbeler book, most of the answer should be in the form of millimeter. So we will multiply this answer into 1000. So after multiply by 1000, we will get our result in millimeter. So deflection at point B will be equal to 150 millimeter. Now what does it mean? It means that if we apply 12 kilonewton per meter load on the beam and the length of the beam 10 meter, modulus of elasticity 200 and moment of inertia is 500, the deflection at point B will be 150 millimeter. This is our main target of our question. Okay, so I have solved this question in detail. If you have any question, if you have any issues related to virtual work method or related to this example, you can feel free to ask me and comment. Thank you.